Okay, good morning. So we will continue with chapter 2, part 2. So yesterday we have seen about the initial lectures, like initial points on thermodynamics and also the properties. So today we will continue with state and equilibrium. So 2.4. Okay, what is state? The definition for state: the condition of a system that all the properties of the system as fixed value. Okay, so as you can see in this figure, so you have first state 1. So m equals to 2 kg, the temperature 1 equals to 20 degrees Celsius, and volume 1 equals to 1.5 meter cube. So this is your first state. Okay, so the explanation is saying that when the properties is having a fixed value and is not changing. Okay, so the condition for a state to happen, so it has a value and it is not changing. Okay, it is not changing until it receive another force for it to change. Okay, so in this case, so if after some time the values are maintained, so we call it as a state 1. And after some time, so let's say you have make changes, so either internally or externally to the system, and in this case, so maybe the piston is moving, so the properties inside is changing. So the mass is still 2 kilogram, the temperature too is still 20 degrees Celsius, but the volume is increasing. Okay, so let's say one of the property is changing and it will come to another state. So we always, if let's say we are referring in our report or whatever, so we are reporting that state 1 is like this. So when if you are changing one stuff, one value, so you need to declare it as a state 2. So if you still declaring it as a state 1, so it will contradict. So it is very important in thermodynamics. Okay, so we have temperature. Okay, so if you can see, so the temperature is having a fixed value in the system. So all the point of the system, so is having 20 degrees Celsius. So meaning it's already reached at equilibrium, so thermal equilibrium. Okay, so we will see what is equilibrium. So equilibrium is a state of balance. So meaning when a system, we are saying a system achieve a equilibrium, meaning it has reached a balance. Okay, so there are few equilibriums available. Okay, so we will see. So the first one is the thermal equilibrium. So thermal meaning is related to temperature. So if a system, we are saying it has reached a thermal equilibrium, meaning the temperature is the same throughout the entire system. Okay, so you can see here. So this is your the initial state. So different point of the system is having different temperature. So you are 20 degrees Celsius, you are 23, 30 degrees. So it means the system is not having a thermal equilibrium because the values in the system is varies. It varies over different parts. But after some time, so let's say you give like maybe 5 minutes or 1 minute or 30 minutes. So after some time, it all the properties will interact with each other and it will become like this. So within the system, it will become the same temperature over all the points. So meaning here, so the lowest is 20 degrees Celsius and the highest is 42. So it will come in between. So in between, so it will agree with one value. So the value that it agrees is 32 degrees Celsius. So meaning once it reach here, so we can say that it has achieved a thermal equilibrium. So this is a common thing in thermodynamics. Then there's another term, we call it as a mechanical equilibrium. So mechanical equilibrium, So meaning no change in pressure. Okay, so mechanical equilibrium is dealing with pressure. So if in the system all the points, so I try to replicate this. Okay, so here is a temperature. So let's say the system is having different pressure over different parts, but after some time it achieves the same pressure throughout the system. So you can say that it has achieved a mechanical equilibrium. Okay, so mechanical is not something related to mechanical part, but pressure as a part of mechanical, so we consider it as a mechanical equilibrium. Okay, so the definition: no change in pressure at any point of the system with time. However, the pressure may vary within the system with elevation as the result of gravitational effect. So this is one important point, because in this surface of the earth, so we are at the normally we will be at the sea level. So always they will say this place is higher, so this place is lower, so above the sea level or below the sea level. So your position where you are investigating the system, it is very important. So how much it varies from the gravitational force. Okay, so normally um, above a hill, so let's say you have a mountain, so you are testing your system on the peak of the mountain. So will the pressure higher or lower? Okay, so anyone can guess. So compared to you being at the sea level, like how you are now. So if let's say you are testing this similar system above the mountain, at the peak of the mountain, will the pressure be high or low? Yeah, who can answer? Yeah. So when we are discussing, try to think also. So what can be the answer?
Peak of the mountain pressure is low.
Okay.
At the sea level pressure is equal
Okay.
normal pressure.
Okay. Good answer. So any other answer other than this? Anyone else? Any other answer? Okay, your friends say at the peak of mountain the pressure will be low. So okay. So it's the acceptable answer. So anyone else with different answer?
As the temperature decrease, the pressure decrease. Maybe.
Okay. So your friend is saying, so maybe the peak of the mountain the temperature is decreasing. So the pressure also is lower. Okay. Okay. So we will discuss on this. Okay. Any other answer? Anyone else? If not, I will explain. Okay. So it's okay. I will explain. Okay. So one friend say is depends on the height. So it will the pressure will vary. So it's true. And temperature. So temperature, um, it is not directly affecting the pressure, but the pressure is differs, as mentioned here, the result of gravitational effect. Because if you are closer to the earth, so which is the core, because the gravitational effect is generated by the core of the earth. So if you are far from the core, the meaning if you are at the peak of the mountain, so you are relatively far from the core of the earth. So the pressure will be lower. Okay, so the pressure difference is due to the gravitational effect, actually. So if you are nearer to the core, maybe at the surface level or at the sea level, so the gravitational will be higher. Okay, so the differences in the height plays a vital role, okay, especially if the pressure is higher. So that's why you take a aeroplane. So your the aeroplane, the system must regulate the pressure so that you can feel like you are on the sea level, because our body is calibrated to the sea level. And if you are below sea level, you are used to to countries like Middle East, like Arab, or some of your friends are from Middle East. So maybe they are in the below sea level state. So the pressure will be higher. So when you are taking a flight, and the system in the flight must adjust so that you will be at ease. Okay, so that's very important. So that's why this subject is very important in our real life, because daily, without we knowing, so we are dealing with a lot of thermodynamic applications. So you need to have an understanding on this. So even for as an engineer, later on you will work as an engineer. So if you are designing something, it is very important for you to have the knowledge of thermodynamics. So you need to take into consideration. So we don't want you to create something at the end no one can use, because it's not suitable with our human body. So all these things are you need to take into consideration. Okay, so then we have a phase equilibrium. So another equilibrium. So if a system involves two phases, the mass of each phase reaches an equilibrium level and stays there. Okay, so this is especially for open system. We have studied yesterday. So if closed system, the mass is not changing, but if it's an open system, mass is coming in and out. So if the mass is reaching uh, equilibrium level between two phase, we can say that it has reached a equilibrium. So equilibrium meaning it already reached a balance, so it will not change until you are making some changes. So phase, so follow the name. So it's related to the mass in the phase. Phase one and phase two must have a equal number or balance mass. Then we can say that it has reached a phase equilibrium. So that's another type of equilibrium also. We call it as a chemical equilibrium. So the meaning, the chemical composition does not change with time. So you, because all the materials, because we are dealing with fluid. So fluid meaning it can be liquid or gas. So in Malay we call cecair ataupun gas. So you can have a fluid in two different form. So when you are dealing with the fluid, so it can be liquid or gas. Okay, so normally gas, so it can have its own chemical composition, so which is gaseous. Or if you are dealing with liquid, so you can have chemical properties of the liquid. So when chemical composition is not changing over time, so meaning it has already reached a balance. So we call it as a chemical equilibrium. So chemical equilibrium is dealing with chemicals. So chemicals, whether in liquid or gas. Okay, so a system will not be in equilibrium unless all the relevant equilibrium criteria are satisfied. So when you have a two phase or two system that you want it to reach a equilibrium, so it will have a certain criteria, equilibrium criteria that you need to meet. So like earlier, uh, we have seen the temperature. So the temperature point must be reaching a balance. So in between, like 32 degrees Celsius. So that is the equilibrium criteria. Until it reach the equilibrium criteria, so you cannot consider it as a equilibrium. I think last week we have seen the mark of hot coffee. So you are eating up at 70 degrees Celsius, but your surrounding is 20 degrees Celsius. So you just leave it over time. So it will reach to a point where uh, it will reach a equilibrium. So normally, if you live over a longer time, so it will come to equilibrium with the surrounding temperature. So until you reach the that equilibrium criteria, so we cannot consider it as a equilibrium. Okay, that is what this slide is saying. Okay, we'll try to recall. Okay, so a state, the condition of a system that all properties of the system have fixed values. So the first state, so we have seen earlier, so it has this mass equals to 2 kilogram. First temperature is 20 degrees Celsius and volume 1 equals to 1.5. And you have after the changes in the volume, so volume is changing. So this is the second state. So every time these values are changing, so you will have a different state. Okay, it's a different state. Yes. So do we need to specify all the properties in order to fix a state? Okay, so there's a question here. So do we need to specify all these properties? Okay, so the answer is once a sufficient number of properties are specified, the rest of the properties assume certain values automatically. So meaning, so each state will have prominent properties that you need to set. And so like this condition, so mass, temperature, and also volume is the prominent one. So, but the system will have other non-prominent values also. So, like maybe the pressure. So it can be the number uh, of number of what else? What else? Normally the system will have. So normally it will deal with pressures. So different pressures. So it can be different amount of chemicals, so it can be either combinations. So all that are not so important. The important one is the mass, temperature, and volume. Okay, for this state. Okay, so different system will have a different properties that you need to have importance. So as long the important properties as achieve the equilibrium, so the other smaller non-prominent properties, it will just assume a certain values automatically. So it's not so important. Okay, so when you're considering a system, so you need to focus on the important properties. So the other non-important properties, so it can be any values. It can be any values. Okay, so that is what this statement is saying. Okay, so then we have another term called state postulate. Okay, so a number of properties required to fix the state of a system. Okay, so that is the number of properties. So like how I say earlier, so the system earlier, it has three number of properties that you need to fix the state of the system. So the mass, the temperature, and the volume. Okay, maybe different system has a different number of properties that you need to fix. Okay, so this is in line with what I explained earlier. Okay, then we have a simple compressible system. Okay, so even though the term is saying compressible system, so when I say compressible system, we automatically will think about a system that we want to compress. But so don't ask me why they name it like this, but this is the term that the engineers and the scientists give. Okay, so it is not really related with the compressible system, but the definition is it is a system in the absence of electrical, magnetic, gravitational, motion, and surface tension effect. So meaning all these effects are not having any influence on the system. So you have a system. If the system is not influenced by electrical effect, magnetic effect, so gravitational effect, motion, and surface tension, so we can consider that it is a compressible system. So automatically the system is not uh, it's like giving you permission to control it, uh, because you can be absent from electrical magnetic, but gravitational is something that is happening naturally, and surface tension also is happening naturally. uh, so if you can control that, maybe in a control environment, so maybe in a vacuum chamber or something, so maybe in a lab, so you can have a special setup that you can control a system. So meaning we can consider it as a simple compressible system. Okay, these effects are due to external force fields and are negligible for most engineering problem. Uh, so mostly we cannot create in because we are dealing with a lot of real life situation in thermodynamic. Okay, so like temperature difference, so we have pollution, and we have environmental issues that we are going on. We cannot solve that in lab, we cannot bring the problem to our lab situation. So normally these engineering problems, we want to find solution for the real thing. So that's why they say here. So normally we will neglect this compressible system unless you want to do some experiment in the lab setting. Then you can consider a compressible system. But since we are dealing with the real life situation, so depends on the nature of the problem. So we can decide whether we want to neglect or not. Okay, so that is what the statement is saying. Okay, then we have a term called independent. So independent system. So two properties are independent if one property can be varied while the other one is held constant. So let's say you have two things. So two things that you want to control two properties. So let's say mass and temperature. So if the mass and temperature is not connected, so meaning one thing is not influencing others, so we can say that it is a independent property. Okay, so independent property. So here say one property you can change, and one more you can maintain it, so you can make it constant. So you can you can say that the two properties are independent to each other. Okay, so for example, here your temperature can be any value for a specific volume of 0.9. So like in this system, so you have a volume or a specific volume of 0.9 meter cube per kilogram, but the temperature, so let's say here 25 degrees Celsius, but you can change it to 20 degrees Celsius or 30 degrees Celsius or 50 degrees Celsius, but the volume is not changing. So meaning the temperature and the specific volume are independent to each other. So earlier also I said, right, your friend said about the pressure difference on the yield and also on the sea level. So the temperature is not directly related. So even at the yield, you can eat up a pot of water. So it is not really related to temperature, but it is related to gravitational. So you can determine whether the system the properties is the property is independent to another one or not. Okay, so the state of a simple compressible system is completely specified by two independent intensive properties. Okay, so simple compressible system we saw earlier. So is completely specified by two independent. So each system, for you to define it, you need to have at least two property. So you cannot have one property and you call it a system. So you must have minimum two. And if the system is having two independent intensive properties, so intensive we have seen. So yesterday's slide you can refer what is intensive. So intensive means is not related to mass. So not related to mass. So if the system is having two independent intensive properties, so we can call it as a simple compressible system. Okay. So we move to 2.5. So processes and cycle. The processes and cycles. So process, what is process? So we always will use this term. So I'm in the midst of a process. So we are having this process, this process. So what is actually this process? Okay, so process is any change that a system undergoes from one equilibrium state to another. So earlier we have seen the equilibrium. So equilibrium means a state where it already reached a balance. Okay, so let's say you are making a change, so you are adding more temperature or you are making a movement. So, from one point of a state, it will move to another point because the properties inside are changing. So, that is what we call as a process. So, you are changing a state where it already reached a equilibrium to another state through a process. Okay, so you can see here the picture here. So you have a property A and property B. Okay, so this is your state one. So let's say you're making changes. So property A may be a mass. So property B may be a temperature. So you are making changes in the mass and also temperature. So it will move from state one to state two. Okay, so state 2. So after some time, it will reach an equilibrium because of your external force. So once it reach an equilibrium, so the movement from state 1 to state 2, this is what we call as a process. Okay, and this process, it will have a path. So like how you are moving from point 1 to point 2. So let's say from Ulu Pao, the Pau Putra campus, you want to go to Kanga. So you need to take the particular road. So you need to take the intersection, everything. So that is the path. So to reach Kanga, so you can take different path. So you can take path A. So maybe you go through Arau, or you can take the Changlun Kuala Police Highway, and you can take the exit at the Kanga intersection, or you can have a different the what we call in Malay called Jalan Bendang, right? So you can take a paddy field road to reach. So maybe the time will be different, but you can have a different path. But your target is to move from Power Putra campus to Kanga. But you can decide which path you want to take. So even this process path are the same. So you can have a different path, but your goal is to achieve state two. So that is what we call as a path. So path meaning the series of states that which through which the system passes during a process. So you have a process here, and the process is going through a path. So that is what we call as a process path. Okay, so to describe a process completely, should specify the initial and final state of the process like here. So this is your state 1, this is your state 2. So maybe after this you will have other states as well until you reach the final state. So you need to know the initial and also the final state of the process, and you need to know the path it follows. So let's say you have two three paths. So which path you want to take, path A, path B, or path C? So whatever number. Okay, so you need to determine it, and the interactions with the surrounding. So let's say in between the process, is it interacting with the surrounding? So meaning the energy is transferring to the surrounding. So maybe uh, since the temperature is changing, so the system can become cold, and because it's becoming cold, so some of the heat is released to the surrounding. So you need to determine whether there are that possibility or not. So you need to check. So that's why yesterday I said, So before you do an investigation, you need to know whether it's an open system or closed system, or it is having various properties change, or it is having external or internal influences. So all these things you need to do investigation before you start a process. So that is what it is mentioning here. Then we have a state. So this is something very important, especially for mechatronic engineers. So a term called quasi-static process or quasi-equilibrium process. Normally, we will call it as a quasi-equilibrium process. So earlier we have seen equilibrium process. So now we will see what is this quasi-equilibrium process. So quasi, I will read first. A sufficiently slow process that allows the system to adjust itself internally so that properties in one part of the system do not change any faster than those of those at other parts. So simply you want to explain this. So are you quasi equilibrium process? So earlier I have told you. So if you want to go from Power Putra campus to Kanga, so you can have different speeds. So let's say you are taking, so let's say you have a train from Power Putra campus to Kanga. So you can go very fast. Okay, so very fast. So let's say you are taking a bus. So it will have slower speed compared to train. And if you are taking car, so you don't need to have a lot of stops, so you can go directly. Or if you are taking a motorbike, so it will have a different speed. So different mode of transportation will give you a different speed. So quasi equilibrium process is a process which give you a very sufficiently slow process change. So you are taking a, so let's say what will happen if you are walking from Power Putra campus to Kanga. So it will be relatively very small path, very slow path, but it will give you more time for you to analyze. Okay, so that is what this quasi equilibrium process is telling. So it is a sufficiently slow process. So meaning it is a gradually it is changing. So slowly it is changing, and because the rate is very slow, because it's very slow, the system can adjust itself internally very fast. So because let's say you are taking one step at a time, so the system every time you are taking one step, so the system is adjusting internally, so that after some time you see like it is not having a lot of changes inside because it is the constant changes of the system. So I can explain to you through a figure here. Okay, so let's say you have a piston. Okay, so piston here you have a pressure one, here you have a pressure two. So if pressure one and pressure two is almost the same, because of the slow compression, so you are moving this piston very slow. So the pressure is almost the same. So it's the changes are negligible. So we call it as a quasi equilibrium. Yeah. So why engineers prefer this? Because they can investigate a lot of things uh, through this quasi equilibrium process. So you no need to conclude everything because you need to have nowadays we have a computer to do the computational, and because computer can calculate a lot of things faster, so you can understand things better. So it was not possible when 20 30 years back because the computers, the processors are very slow. But now it is possible because you can do a lot of calculation faster. So if the system can adjust itself internally, and you as an engineer can understand things in a faster way, so we consider it as a quasi equilibrium. So you can do a lot of investigation. Uh, and if the compression is very fast, so let's say you apply a lot of force and it is changing very fast, so the pressure 2 equal more bigger than pressure 1, so it's not almost equal, so we call it as a non quasi equilibrium. So you as a scientist or engineer, when you have this non quasi equilibrium condition, so it will make your life hard to do calculation or estimation. Okay, so that's why we always in physics. So I believe you all from the physics background. We will have a lot of assumptions that we make before you do a calculation. Because when you make assumption, so you can reduce a lot of complexity. Okay, so quasi-equilibrium process is an idealized process, not a true representation of the actual process, but many actual processes closely approximate it. So quasi-equilibrium is an idealized process. So we always wish for it to be that way, so that we can do a lot of investigation. But it might not the true representation of the actual process. Maybe in an actual condition or the real life condition, things may happen very fast. So you cannot expect the nature to follow your instruction, right? So it will do whatever. So we as the engineer, we as the human being, we need to do uh, a lot of things faster for us to understand things. That's why we having a good faster processors like this gaming laptop. Also you can see the processor is much faster, or we have a supercomputer which can calculate things very fast. So all these equipments so will be very useful for us to do investigations. Okay, so engineers are interested in quasi-equilibrium process due to easy to analyze and work producing device deliver the most work when they operate on quasi-equilibrium process. So as I mentioned earlier, so we it will be much easier for us to analyze, and so we can do a lot of processing much faster in quasi-equilibrium process. Okay, so solid. We have seen earlier initial state and also final state, state two. So let's say this process is only this system is only having 1.1 and point 2, the point 1 is initial and final, because a lot of process can have state 1, state 2, state 3, then maybe state 4 is the final. So you can have a different. So this is considered a simple system. So the changes in the volume. So volume 1 to volume 2. So when it change from initial state, it will moving to state number 2, which is the final state. So if the process is a solid line part, so meaning this is a solid, so this is all connected, so we call it as a solid part, so we call it as a quasi equilibrium process. So if the process is having a dash line, okay, so we have a dash line like this. So let's say we have here the green color line is a dash line, so we call it as a non quasi equilibrium process. Okay, and we also always will use a prefix called iso. Okay, iso means balance. Okay, balance. So it will be used to designate a process for which a particular property remain constant. So if something is in balance or remain constant, we call it as we will add the prefix iso. Okay, for example, isothermal. So isothermal. So if in an exam question I'm giving the condition is isothermal, so automatically you need to understand that it is a process which the temperature remain constant, because isothermal. So iso is balance. Thermal means it's related to temperature. So meaning it is a process which the temperature remain constant. Okay. Then we also have isobaric. So baric Baric is always related to pressure. Okay, so barometer. So barometer is a device to measure the pressure. So from there we have this term baric. Okay, so iso balance. So baric is the pressure. So process is the process. So it means a process which the pressure remain constant. So if the question is saying it's an isobaric process, you automatically need to know that it is a process which the pressure remain constant. Okay, then we have isochloric. So isochloric process or isometric process. So when it has a chloric meaning, so it's always related to volume, or metric. Metric also is related to volume. Okay, so if these terms this term is used in your exam question, so you need to know iso means balance, chloric means is related to volume. So it is a process which the specific volume remain constant. Okay, so the volume remain constant. Okay, specific volume is divided by mass, so it's still related to volume. Okay, then we always encounter this cycle. So we always refer to something as a cycle. So cycle is actually a system undergone a series of state. The initial and the final stage are identical. So meaning, so earlier I say a process will start from state one, it will move to state two, state three, state four, and maybe the process will end at the state four. So if that's the condition, so that is not a cycle. But if the process is moving from state one, two, three, four, and at the end, state four, it comes back to state one, so state 4 and state 1 are the same. That we call it as a cycle. So state 1 and state 4. So meaning state 1 is the initial and state 4 is the final state. So both having the same value. So we call it as a cycle. So it will go round and round. So depends on how many cycle it will your system or the process is having. Okay, then we always in thermodynamics we use the term steady. Steady means it's not the steady that we are using in the real life. Steady in thermodynamic means no changing with time. So meaning from, let's say you are having hot water. Okay, so let's say you are having it now. So maybe after 1 minute, so the temperature is not changing. So meaning it is a steady condition. Okay, a steady thermal condition. But maybe after 1 hour the temperature is changing or is reducing. So from steady it becomes non-steady because over time it changes. Okay, so normally we won't take like 1 minute, so we will take for maybe 15 minutes or half an hour or 1 hour. So because we want to investigate how much the system is changing over time. So a bit longer. So maybe if is a shorter time, it's still in the quasi equilibrium state where uh, you cannot observe a lot of stuff. So at times your investigation requires you to observe at a slower rate. But if the application requires you to do investigation at the faster rate, so the quasi equilibrium might not be helpful. Okay, so steady means it's related to time, and we have this uniform. People always will confuse. Before we know all these terms, we always will mix and use. In Malay we call it campur again. So campur and use. We can, after this you know. So what is steady? What is uniform? Steady means is something related to time. Over time is not changing. The properties are not changing, and uniform means so it's not changing in terms of location. So if it's in this location, it remain at that location for a longer time, a particular moment. Okay, so no change with location over a specific region. So let's say your system is big, and you're only investigating maybe a small area. So the area or the matter is not changing, it's not moving to different location over time. So it's being uniform in at one place. So that is what we some terms that we are using. Then the final slide for today, steady flow process. Okay, so in this chapter we are learning about different thermodynamic terms. Okay, for today this will be the last term that we will be learning, steady flow process. So steady, earlier I said, is the related to time, and flow process meaning the fluid is flowing, so it can be liquid or gas. It's flowing from one point to another point. So when you are having that, so meaning you have a flow. So if it's only being at one location, so it is not a steady a flow. So meaning it's not moving from point one to point two. Okay, so we will see steady flow process mean a process during which a fluid flows through a controlled volume steadily. So you have a point one here, so mass is entering. So this is your control volume, and the mass is going up. So this is at the time 1 p.m. Okay, so you have a time, because it's a steady is related to time. Okay, so and you see the control volume, it is not having a thermal equilibrium yet. So here 300 degrees Celsius, here 250, here 200, 150. So maybe the mass entering uh, is a is a bit odd, and when you go out of the system, it's becoming cold. So maybe this is a heat exchanger. Okay, but what will happen after 2 hours? So after 2 hours, so mass is entering and mass is going out. The and the system is still having the same thing. So here 300 degrees Celsius, here 250, here 200, 150, same like at 1 p.m. So at 3 p.m. also, everything the same. Then we know that there's a flow, and the flow is steady flow process, because it is a process during which a fluid flows through a control volume steadily. Okay, so that's all for today. So, do you have any questions? Okay, so today I couldn't ask a lot of questions, but I hope you understand. So, if you don't understand, please listen, because all these terms, when you are using in this subject, especially in thermodynamics applications, you need to make sure you use the correct terms. So now chapter 2 we are learning about different terms, and you need to understand each term, because it will be tested in your quiz, it will be tested in your midterm exam. So that time you cannot have any reference. So you need to keep on practicing and understand this thing better. Okay, so any questions? No questions? So if no questions, we have 5 more minutes. So I will pass the attendance list. Okay, so today we have 30 students. So make sure only 30 numbers are there. So because this Google Meet can generate the attendance list by itself, but I will pass you the attendance list like yesterday. So I won't give QR code. I will just give the link, so that you can fill. So make sure it tallies with whoever attends you. Okay, so please hold on. So I will stop the recording first. Okay, recording like yesterday, I will put it in the Google Classroom later.